Debug menu for the grid. Okay, so today we're going to create a debug menu for our grid, because right now, if you remember, in the last video we were able to spawn a grid and edit the settings, but it's only possible to do it in editor right now. So we're going to create a new tab for the grid with a debug menu with all the options we need to spawn the grid, change the settings, make it bigger, smaller, and even destroy it. And all that while playing the game. Anyway, let's get to it. Okay, in Unreal, there's a few things I want to clean up before we start building our tab, and the first thing is those planes. If you remember in the previous video, I created those planes so we have a better understanding on how the grid behaves, but right now we don't need it, so I'm just going to delete all of that, all the grids and all the planes. Perfect. I also want to make sure that I only have one grid in all my levels. Actually, I just want to have one grid in the persistent level and no grid anywhere else, just one. So I'm just going to hide all my levels and make sure that in my hierarchy, I only have one grid, and it is in the persistent level. Perfect. I'm just going to show these levels back up. And the last thing I want to do is to make sure that these planes, the ones that we were using to build our levels, are hidden in game, because we don't want to see them while we are playing the game. Because right now if I press play, oh, actually my level is not loaded, so I'm just going to right click on square, change streaming to always loaded. And now if I press play, I see both my grid and the grid plane that we used for the level design. So I'm just going to hide that grid. I don't want to delete it, I just want to hide it. And to do that, I'm just going to select my plane and scroll until we get to the rendering category. In here, there's the second checkbox, actor hidden in game, so let's just check that one. So right now, if I press play, we have our grid, the level, but we don't have the plane in the back. Perfect. We're gonna do that for all the other levels. So I'm going to show the hexagon, select the plane, go all the way to the bottom, check the checkbox to hide it in game, and then I'm gonna do the same thing for the triangle. Select the plane, hide it in game. Perfect. And now I'm just going to show my square level back, and we are ready to jump in the code. But before we go edit the user interface, there's a few things I want to change in other blueprints. And the first one is the camera zoom, because if I press play right now, I start really close to the ground, and I don't like that. So I'm just going to go in my pawn. So in blueprint, core player, open the pawn, and in here I'm going to select the spring arm component and adjust the target arm length on the right there. I'm going to write 3500. Which should be way better than 700 that we had before. And right now if I press play, I have a way better view of my whole level. And now the second thing I want to fix is the grid flickering right there that you can see. And the reason why it is happening right now is because the grid is at the exact same height as my floor, the exact same height. And that's why there is some Z fighting in between those. So we're just going to move the grid up a little bit, just a few units, just so the grid is right above the floor. So I'm just going to stop and go in the grid, so core grid BP grid. And here in the spawn grid function where we are setting the tile transform, I'm just going to drag from the tile location and add a tiny offset. So I'm going to do a plus, so vector plus vector, and I'm going to add 2 in the Z. That way the grid is going to be 2 units a little bit higher. So I'm just going to attach them together and move the node in place like so. And now if I compile and go see in the level, there's no more flickering. Everything's perfect now. Great. And there's one last thing I want to do, and it is to make sure that the grid doesn't spawn on BeginPlay or in the construct in that case, because we want to be able to spawn it via the user interface a little bit later in the code. So I'm just going to go back in the grid and I'm going to go in the construction script. And in here, I'm just going to detach the spawn grid function from the construction script. You can do that by holding Alt on your keyboard and clicking on the link. You can now compile, and if you go back in the level, you should see that the grid disappeared. Okay, we still have the default grid tiles that we added at the beginning, so I'm just going to remove them also. So go back in the grid, select the instance static mesh component on the left, and if you scroll down to the instances on the right, you can simply click on the trash can to remove everything. Here we go. Now if I compile, save, and go back in the level, I don't have anything in my level anymore. Perfect, we have an empty grid to work with. And the first question we have to ask ourselves is, what are the variables we want to expose into our debug menu? So if I select my grid and go on the right there, we have the grid center location. Yeah, that's good, we want to edit that. Grid tile size, that's good also. Grid tile count also, and probably the grid shape also. So okay, we are going to expose all that, perfect. If you remember when we did the camera tab, we created a spin box, a custom spin box, with a float on the right and a name on the left. But in this case, the variable types are not floats, they are vector2d and vector3. So we also need to create some custom spin box that let us have 2 floats on the right and a name, and 3 floats on the right and a name. So that's what we're gonna do. I'm just going to go where we created the first spin box, so it's in debug menu, widgets, and here it is, spinbox underscore with name. I'm gonna start by opening it because there's a little something I want to change in there, and it is in the graph here. I'm just going to go back in the event graph and go right here where the value change event is called. And the thing that I want to change is to make sure that this value right here is updated when the value on the spin box is updated by the player. Because otherwise only the value on the spin box is updated but the value variable is never updated, which breaks the link between them. So let's just get the value on the left and do a set, drag the pin of the value coming from the event in there, connect it after the gate, and we can connect it to the callback, like so. So now the value is updated at the same time as the spin box. Perfect. We can now compile, save, and we can close this one. And it's now time to create the second spin box. And to do that, I'm simply going to duplicate the one that we created before. So I'm just going to drag it right here and click copy. And I'm going to rename it, so spinbox underscore with name underscore vector2, because this is the one that's going to be used for the vector2ds. And then we can open it. We already have a few errors, but we don't care about them for now. And we are going to focus on the designer side. Here I have my spinbox, which is inside a border. And that's all good. So what I'm going to do is simply duplicate the border. So Ctrl W, it's going to duplicate the border and the spin box. So we are now with 2 spin boxes inside our widget. Let's rename them a little bit. So spinbox value underscore X and spinbox value underscore Y. Then you can edit all the settings if you'd like, but in my case, I don't really mind. They are perfect the way they are. Good, let's go in the graph. Here we're gonna have to change a few things, starting with the value on the left, our variable. Because right now it's a float, but we want it to be a vector2d, so let's change the type. Search for 2d and get a vector2d. Unreal is going to ask us if we are sure that we want to do that. Just click on change variable type. It's going to cause a few errors and open the find in blueprint. We can just close it, it doesn't matter for now. And the next thing we want to change is the variable type on the value change callback. So let's just go change that. Input value, I'm going to change the float to a vector2d. And the last place we want to change the variable type is in the set value function. Same thing, float, change it to a vector2d, like so. Now we can compile, save, and we have a bunch of error to fix. And I'm gonna start with the onValueChanged event right here. First, we need a second event. So let's just select our second spinbox on the left, so spinbox value Y, and create the onValueChanged event right here on the left. We can connect this event to the same place as the previous one, so connect it to the gate. Then I'm gonna disconnect the link from the first spinbox, like so, and I'm going to move on the right a little bit. We can connect the node like that instead of the previous link. Then I'm gonna split the value, so split struct pin of our values right there, and we're gonna get the values directly from the spinboxes. So get the spinbox, get value from them, and connect them to the set. So that was for the spinbox X. I'm gonna do the same thing for the spinbox Y. Like so. So now when the spinboxes are updated, they are feeding the value directly into the variable and calling the callback. Perfect. Save that. The error list is getting smaller. Let's just go see the next one. I'm going to click on the link right here and it brings me right there. So where the set value is called from the variable. I'm just going to connect them like so. Okay. Now the next one, okay, this is inside the set value function. Okay, that's not too hard to fix. I'm just going to take the value, connect it to the set, break the broken link like so. I'm going to split the value, connect the X into the set value for the spinbox X, and I'm just going to do the same thing for the spinbox Y. So I'm just going to do that, replace the X by the Y and connect the Y pin into there. Compile, save. Okay, that's perfect. It's all good. We don't have any errors anymore, but it doesn't mean that we did everything we needed to do. And it is because, let's say if we go back in the event graph here, at the beginning in the pre-construct, we are setting a bunch of values on the spinbox X, right here, right there, not this one, doesn't matter, this one right here, here, and here. So we want to set all those values also on the spinbox Y. But instead of duplicating all the code and connect it, I'm going to use a for each loop. So I'm just going to move this down. I'm going to take my two spin boxes here and there. I'm going to make an array out of them, so make array. Connect them both to the array, drag from the array, search for each loop, like so. And I'm going to connect it to the for each loop after the set text, and then the loop body is going to be all the set variables right there. And for all the set variables functions, I'm going to replace all the spinbox value x by the array element of my for each loop. So we can just hold Control and drop them onto the for each loop. Then do the same thing for the next one. Then I can delete the two spinbox x nodes, and I can align a little bit. Actually, these two right here don't really fit in the for each loop, so I'm just going to cut them and move them out of the way for now. Okay, I'm going to align stuff properly, like so. And we can now bring the next batch of code. So this one, and that one. So I'm just going to bring them a little bit closer, connect them to the rest of the loop, and then take the x, connect it to the array element, delete the x right here, connect this one to the array element, delete the node, and the last one right here, I'm going to get it and drop it onto the for loop and delete the node. And then we can bring it a little bit closer to each other. Okay. So now we are using the for each loop to set everything like so. So we are setting this one, that one, that one, that one, that one, these ones also. Perfect. So now all those variables are set onto both spin boxes. And for the last bit of code right here that wasn't supposed to be in the for loop, we're just going to put it before it. So I'm just going to move everything back to the right, like so. And I'm going to put that right here. Okay, perfect. We're done with the spin box. We can compile, save, and close this one because we don't need it anymore. Okay, so for the third spin box, it's going to be the exact same thing as the previous spin box, but with an extra parameter at the end. So we're going to duplicate this spin box with name underscore vector 2 to create spin box with name underscore vector 3. We can save it and open it. Here it still doesn't compile, but we're gonna fix that later. And we can just start by focusing on the spin boxes. Here I'm gonna do the same thing. So I'm going to duplicate the border above the second spin box, which is going to create me a third spin box. I'm going to rename it to spinbox underscore value underscore z. And while I have it selected, I'm going to go on the right at the bottom completely and create the event on value changed, which is bringing me into the graph. So I'm going to come here and connect the execution pin out of the event into the gate like the other ones. And I'm going to click compile to see all the errors. Okay, but actually before fixing them, I'm going to change the variable types. So I'm going to select value on the left and change it from a vector2d to a vector. Yes, we want to change the variable type and close this window, it doesn't matter. Then we want to do the same thing for the callback. So the event dispatcher right here, we can change the variable type from the vector2d to a vector. And we have to also do the same thing for the set value function right there. We have to change it from a vector2d to a vector. Perfect. We can now compile and see the error list for reals. And we are going to start here, like the previous one. I'm going to connect the set to the callback, and I'm going to set the value of my z. So I'm going to duplicate those nodes, connect them to the z, and replace the y spin box with my z spin box, like so. Let's compile, and we can now go to the next error. Click on it, it brings us here. Perfect, let's just connect them together, like so. Compile, next error, go there. Okay, in the set value, I'm just going to connect it. Delete the previous link, and we also have to set the value of the z. So let's copy those nodes, connect them with the previous one, connect them to the z, and replace the spinbox y by the spinbox z, like so. And the final thing we have to do is to add the spinbox z into our for each loop. So let's go back in the graph and at the beginning in the pre-construct where we are looping through our spinboxes to set the default values, we are going to add a third pin and connect the spinbox z inside it. And that's it, we're done with the spin boxes. So let's compile, save, and we can close it. Okay, it's now time to go build our tab. So I'm going to go in the tabs right here, and I'm actually going to be lazy, and I'm going to duplicate the tab console commands and rename it to tab underscore grid and open it. The first thing I'm going to do is rename the tab right here, and instead of console command, I'm going to rename it to Grid Generation. Same thing, I'm going to rename the expandable area to Grid Generation. And then we still have all the buttons and everything we add in our console command tab, so I'm just going to select all that and delete them. Then if I compile, Unreal tells me that there's an error. I'm going to click on it and go see it, and it is the code that we used for the console command tab. I'm just going to delete everything. Here we go, let's compile, save, and that's it. I can go back in the designer and start building the grid tab. So we're gonna use our spin boxes. So I'm just going to scroll all the way down right there, and I'm gonna start with the spin box vector tree. Let's drop it in the vertical box. We're gonna change the default settings. So for the name, it's gonna be location. The min-max value are gonna be minus 100,000 maybe, doesn't really matter. And 100,000 for the max. The min-max slider though, it's gonna be minus 1,000 and max 1,000. For the default value 000 is good because we're gonna spawn the grid in the middle of the world. Then the fractional digit, we can leave it at 1 and 1, doesn't really matter. We don't want to always snap to delta, and the delta is gonna be, let's say, 10. Now for the second spin box we need is a vector 2, so let's grab it and drop it into the vertical box and go change the default settings. So the name is gonna be tile count. For the min-max, let's say 0 and 100,000, doesn't really matter for the max. For the slider, we're gonna go with 2 and 50 for min and max. For the default value, let's say 20 by 20, so we're gonna start with a 20 by 20 grid size. And then the fractional digits are gonna be 0 because we don't have half tiles. We always snap to delta, and the delta is gonna be 1. And the last spin box I'm gonna need is gonna be a vector 3 again, and I'm going to rename it. So it's gonna be tile size. For the min-max, let's say 0 and 100,000. For the min-max slider, let's say 50 and 400. The default value is gonna be 200, 250, let's say. The frac digit are gonna be 0. Always snap to delta uncheck, and the delta is gonna be 10. Now we should also rename our components. So let's say spin box with name underscore location, spin box with name underscore tile count, and spin box with name underscore tile size. Then I want to align all those spin boxes right there. So I'm just going to change the name and add a few spaces in there until they are all aligned together. Something like that. And now we need one last thing, and it is the grid shape right there. So we want to have a combo box right there, like a drop-down menu, with all the grid shape choices we have right there. So we want to have the exact same thing into our tab, which is easy to do. We're just going to search for combo box string, and I'm actually going to place it at the top right there. Then I'm going to rename the component, combo box string underscore grid shape. And then we have to set our default options on the right there. In this case, we need 4 elements, so the element none, triangle, square, and hexagon, so 4 elements. And we actually want to have the exact same words and the exact same order of the words that we have in our enum. So let's just go copy from it and paste it there, just to make sure that they are all the same. So I'm going to go back in entry, go in grid shapes, and open the grid shape. Then I can copy the enum value, so none, copy, paste here. Then square, copy, paste here. Then hexagon, copy, paste here. And finally triangle, copy, paste here. We can close the enum because we don't need it anymore. And then we have to tell which option we want to display by default, and in my case it's the square, and I'm going to paste it into selected option right here. And now if I compile, I should see my square appearing in the combo box. Now I'm just going to adjust the visual of the combo box. So first I'm gonna add a bit of padding, so let's say 2 in padding. Then I'm gonna expand the style, then expand the combo button style, then expand the button style, then expand the normal style, and I'm gonna change the tint right here. And I'm gonna change it to something really dark, something like that. Then I'm gonna close the normal style and open the overt style and do the same thing. Tint, a bit dark, but less dark than the previous one. And then close the overt, open the pressed, change the tint from super dark to a little bit less dark. Something like that. We can collapse all the style and go in the font. Here, instead of bold, I'm going to make it regular, and the size is going to be 10 instead of 16. And the last thing we have to change is the color of the text. So the foreground color, here I'm going to make it all the way white. Here we go. Now if I compile and save, I can now see my new combo box with the new visual. Next thing we can do is make sure that the tab grid is spawning inside our debug menu. So let's go back in N3, go back in the debug menu and open the W debug menu. Here I'm going to rename my tab 3 here tab that I have at the top for grid. And I'm also going to change the button name. So button underscore grid and the text underscore grid. And here in the widget switcher, I'm going to change the fourth child from this thing to my new tab. So I'm going to scroll all the way down and get tab underscore grid and drop it into the widget switcher. And I'm actually going to make the grid tab visible by default. So I'm going to select the widget switcher and go on the right and change the active child index to the index 3, which is our grid generation tab. Perfect, I can now compile, save, and let's say if I go play in the game, the tab is visible. Great, we can close it and open it and everything. Okay, let's go do the logic now. I'm gonna go in the tab grid and I'm gonna go in the graph. Okay, so the first thing we need is to access our grid that is right here in the world. And since it is the only grid that is in the world at the moment, we can simply use a getActorOf class to access it. So I'm going to go back in the tab grid and search for getActorOf class. And what this function does is loop through all the actors that are in the world and find the first actor of the class that we ask for. So in this case, we want a BP grid. So I'm going to change the actor class to BP grid. So now the function is going to loop through all the actors in the world until it finds a BP grid. Any BP grid. So if you have 10 of them, it's going to pick one randomly, the first one it finds. But in our case, it's going to work because there's only one actor. Okay, so this function is giving us access to the BP grid, but it is pretty expensive, so we don't want to call this function every time we want to access the grid. Instead, what we're going to do is save the grid into a variable, and then we can use the grid via the variable. So I'm just going to right click on the return value and click on promote to variable, which I'm gonna name grid. And we're gonna do all that at the beginning of the game when the widget is created. So drag from the getActorOf class and search for event construct, like so. So now our widget have access to the grid, the first grid that it finds in the world. Great, so now what do we want to do with it? Well, we want to change the grid every time any of our variables is changed in the UI. So let's just start by creating the events of all of our spin boxes. So the location, create the onValueChanged event. Same thing for the tile count and same thing for the tile size. For the combo box of the GridShape is a little bit different because it's not a spin box, but it still has an event that is called onSelectionChange, which is called when the selected element of the combo box has changed. So let's just click on that one. And then I'm going to bring them all close together. And actually, since we are going to call the same code for anything that changed in the widget, we are gonna link all the execution pin together. So I'm just going to drag from any of them and scroll all the way at the bottom and add a reroute node. Then I can just drag the other ones onto it. Like so. And then from here, what we want to do is to update the grid based on all the new parameters. So let's just grab the grid and call the spawn grid function. We can connect it to the events. And here we have to pass it all the variables. So I'm going to start by grabbing the spin box location on the left and do a get value on it. Get value, which I can connect it to the center location of my grid. Then I'm going to do the same thing for the tile size. So get on the left, get value, so, and connect it to the tile size. Then same thing for the spin box tile count, get value, and connect it. For the grid shape, it's a bit different because it is a combo box, so let's grab the combo box first, and then you can get selected index, which is the index of the selected value in the combo box. Same thing as the index that we have right here, because we have the same exact order in our enum and in our combo box. So we can convert the index from the combo box to the index of our enum. And to do that, we have to convert the int to a byte first. So to byte. Math conversion to byte, the last one right here. and then we can simply drag on top of the shape. And just like that, everything should work. So we can go try it. I'm gonna compile, save, and go in the level, press play. Here my grid generation menu is open, my grid is not spawned, but as soon as I change something in here, so let's say hexagon, I have my grid that is spawned. Perfect. But it will also be nice to have the grid already spawned at the start. So let's just stop and go do that. I'm gonna go back in my tab, and I'm going to collapse all that into a function. Right click, collapse to function, which I'm gonna name spawn grid. And I'm going to call this function at the beginning of the game. So after we set the grid, we call the spawn grid function. Let's compile and go press play. Okay, I started the game and I have my grid. It works, but there's one thing that I don't like about it. And it's that it doesn't use the default values that were on the grid that was in the level already. So let's say if I select my grid right there, it should have been a grid tile count of 10 by 10. But when I press play, I have a tile count of 20 by 20. So we have to do the same thing we did for the camera, and at the beginning of the game get all the variables that are on the grid and use them to set the status of our widget, all those pin boxes there. So let's just stop and go do that. I'm going to go back in the tab grid, and since there's a ton of variables to set, I'm going to create a function right away. Create new function, which I'm gonna name set default values. And in here, I'm going to get all the components and link them to the proper variable from the grid. So we're going to start with the grid location. I'm going to drag the spin box, do a set value on the spin box. Then I'm going to grab the grid, do a get grid location, get grid center location, this one, and connect them together, like so. And then we have to do the same thing for the other ones. So the next one is the tile count. So I'm going to do something like this. Gonna grab the tile count spin box, grab the tile count variable from the grid and do a set value with it. Then the next one is the tile size. So here it is. I'm getting the spin box tile size and getting the tile size from the grid to set the value of the spin box. And for the combo box, it's a bit different. So we're getting the combo box, do a set selected option, this one, the second one. We can connect it like so. Then we need to get the shape from the grid, so get shape. And since both the combo box and the enum have the same element typed exactly the same way, we can convert the enum to a string and it will work. Something like that. And that's it. Now we just have to make sure that this function is called at the beginning of the game. So in event graph right there, after we set the grid, but before we spawn the grid, we're gonna call the set default value function right here. So we set the grid, we set the default value of our widget, and then we spawn the grid again. Compile, save, and then if we press play, I now have a grid 10 by 10, like it was written in my BP grid in the level. Okay, so here everything seems to work perfectly. If I change my location, the grid moves. If I change my tile count, it works also. Same for the grid tile size. And also if I change my grid shape, it also works. But we actually have two little things that are not really working properly. And the first one it is that if you change the grid shape to none, it just spams us with a bunch of error. The grid disappears, so it works kinda as expected, but we have a bunch of error. So it would be nice to be able to set the grid to none without being spammed. So let's just go do that. I'm gonna stop and go in the tab grid. I'm gonna go in the spawn grid function. And the reason why we are spammed every time we are setting it to none is because we are trying to spawn a grid with none. So instead of trying to spawn it, what we're gonna do is simply destroy the current grid, which we can do by calling grid destroy grid. So let's call this function instead of the spawn grid function when the selected index is equal to none. So let's just go do that. I'm gonna move this over here and I'm gonna drag from the enum right there. And I'm gonna do a equal enum, the last one. If it is equal to none, so that's good, I'm gonna do an if here, connect it, like so. If it's equal to none, we destroy the grid. If it's not equal to none, so if it's false, it's gonna spawn the grid shape that we are asking. Perfect, let's go compile, save, and test. Play. Now my square grid works, triangle, hexagon, all good. And if I press none, I'm not spammed with a bunch of errors and I have no grid in my world, so it worked as expected. Perfect. And the second problem is actually performance related and it's a bit more trouble to fix. but we're still gonna fix it. But first I'm gonna go in command and show my FPS with stat FPS. You can see it on the top right corner. And now if I increase my tile count to, let's say, a ton, let's say 50, we can see that if I scrub right there, I have a bunch of lag spikes. It's not that great. But if I click on the spin box instead and I write a number, so let's say 100, I didn't have any lag spike. 200, no lag spike. 50, 40. So why aren't we able to have a smooth experience when we are scrubbing in the spin box compared to when we are writing a number, even though the number we are writing is way bigger than the one that we are scrubbing in the spin box? Well, this is because the spin box is actually updating every frame. So every frame, if you are dragging, so if the number is different than the one from the previous frame, it is going to call our callback, which is going to regenerate the whole grid. So every frame, when we are scrubbing the spin box, it generates a new grid. So it generates a ton of grids, and that's not good. So to fix that, I'm just going to add a small delay in between grid generations. So that way, if we already generated a grid, let's say 0.5 seconds ago, we're not gonna generate a new grid. We're gonna wait until the next changes. So how do we do that? Well, I'm gonna stop and go back in the type grid. And I'm going to go in designer because we're gonna need a new variable. So I'm going to add a new slider in there. I'm going to go in user created and go in spin box with name. I'm gonna use just a float this time. And I'm actually going to place it in between the combo box and my other spin boxes. For the name, I'm going to name it regen delay, I guess, something like that. For the max value, I can maybe set it to 5 seconds. The min-max slider, let's say 0 and 0.5, because we don't really want to go above 0.5 seconds, it's not really useful. For the default value, maybe 0.05. Which doesn't appear right now because the fractional digit is not set properly. So let's say 2 and 2 for the fractional digits. Always snap to delta. No, we don't need to always snap to delta. And the delta is going to be 0.01. Now I'm just going to rename my component. So spin box with name underscore regen delay. And we don't actually care about the event for that one, because we're not going to trigger anything when the regen delay is updated. So let's just go in the graph. And I'm going to go in the event graph. Right here. So what we're gonna do is block the flow here until the delay is completed. And to do that, we're gonna use a do once node. So do once, this one. And what I'm gonna do is connect all those nodes inside it. So it's gonna execute only once until it's reset. And once the grid is spawned, we're gonna reset it. So I'm just going to connect it back to the reset like so. Then I'm gonna double click on the link just to move the link around a little bit, just so it's cleaner like so if I put it that way. And now in between the do once and the spawn grid, we're just gonna add a small delay so we don't spawn the grid every frame. So I'm just going to get the spin box from the left, so spin box regen delay here. Do a get value on it to get the current value, and I'm gonna add a delay node like so. So that way, even if these events are called 60 times per second, this pin right here is going to fire only once. Then it's gonna wait a small amount of time, it's gonna generate a new grid, and then it's going to reset the do once. So that way, this event is going to fire another time, just once. And then it's gonna loop until these events stop firing. But anyway, it should all make more sense when we're gonna test it. So compile, save, and go try that. Press play. Now if I scrub in the tile count, I don't have any lag spike, like it's super smooth. And I don't even feel any difference, even though I now have a small delay between the moment I change the variable and the moment that my grid is updated. But it makes the experience way smoother. But let's say if you increase the regen delay to 0.5 seconds, now you're gonna feel the difference because the grid is only gonna update every 0.5 seconds. Like so. But you can use any value in between and it should work perfectly. So you can choose the value you'd like. Let's say like 0.1, it's good. 0.2 is good also. 0.5, I think it's a bit much, but anything in between, I think it's pretty fine. But anyway, that concludes this video. We're gonna add more features into this debug menu in the next one. So see you then. Bye bye.